All right, let's take a look at some control structures for looping and flow of control in C#. We'll start off with a blank solution in our blank project in Visual Studio, and we'll just create a for loop. So this will be a simple for loop for counting iterations. So for, and then I can actually create my loop parameter in the condition of the for loop. So I'll say int I, set that equal to 0. That's a common C idiom. And then I is less than 10. So typically the way it's done in C, you start at 0 and you go to less than whatever the number you're counting to. So basically this is a loop that counts through 10 times. And what I'm going to do is I'm going to increment my counter, my loop parameter I, each time. And a for loop has a body that's usually presented as a block statement, but recognize that a block statement really is exactly one statement. So what we're actually saying here is that a for loop has a one statement body, like so. And so in this case, I'll just print the value of I, and then run that code. And you see the numbers 0 through 9, indicating that I executed the loop 10 times, but again started at 0. So that's a single statement in a for loop. This is also a single statement, but that single statement is in the form of a block, and so that means that I could put additional statements in here. For example, I could create another variable or do whatever I like. But of course, if I did create a variable, its scope would be limited to this block statement. So there are three parts to the header of a for loop. The initial condition, which in this case the initial condition is declaring a loop parameter I and setting it equal to 0. The test condition, which in this case is checking the value of I, and as long as I is less than 0, the loop will continue. And the post condition, which in this case is iterating I. So the flow of control here would be initialize, test, do the loop body, however many lines that is inside of a block statement, then do the post condition, and then based on that do the test. This is the standard form, but of course you can put any code you want as part of the initialization, as part of the condition, or as part of the post condition. So for example, this is an infinite loop, because it's legal to leave everything out other than the semicolons. And so you'll actually see this done quite a bit in C. It's not done so much in C#, but nonetheless it is a legal statement that means infinite loop. And just as a side note, if you think of all infinite loops as being bad, I used to have a friend that said that if you thought all infinite loops were bad, he didn't want you programming his pacemaker. So in other words, infinite loops definitely have a place, and very often you'll see those used in embedded systems and things like that. Well, this is the most common form of a for loop. You will also see, as I showed you, the infinite loop as well as a countdown situation. So here's the same loop in reverse. Now, it's also certainly possible that you could put any statement here. It doesn't even have to be related to the loop parameter I. I would caution against it. In general, incrementing or decrementing your loop parameter by something other than 1 is just a recipe for inserting bugs into your code. If you really need that behavior, we have other things that would do that better. For example, let's say that you only wanted the even numbers. So here's a for loop. Under those same conditions, but if I modulus 2, so the modulus operator is used to divide the left-hand side, which in this case is I, by the right-hand side, which is in this case is 2, and then produce the remainder. So if I divided by 2 is 0, then that means it's an even number. So we say that I mod 2 is 0 means even number. And obviously the opposite, I mod 2 1, that means it's an odd number. So then the question is, what are we going to do if that's the case? So let me move this comment up. And the answer is, once we've done the comparison, if we only want even numbers, then if I mod 2 is equal to 1, this is an odd number, and we want to ignore this execution, the statement for that is continue. So let me put a couple of output statements in there so we can see how this proceeds. Okay, so what continue does is if it's executed, it means the remainder of the loop is abandoned, and we go back to the top, do the increment, and do the test. On the other hand, if I mod 2 is not equal to 1, then we won't do this continue, and that means we're going to hit the after continue statement. So let's put a little bit more I/O in here so we can see this happening. And let's run that code. And as you can see, we do before and after on the even numbers. But for the odd numbers, we do the before continue, but we don't execute after continue because the loop has been abandoned at that point. So that's the use of the continue statement. And we could trace that through using the debugger. So what I'm going to do is I'm going to comment out these other loops so they don't interfere with what we're trying to show. And I'm going to step through my code. Now, if you go up to debug, you can see that we can start debugging or start without debugging. And what we've been doing a lot of times as we do the demos is Control F5 to run the program not through the debugger and get the console window to stick. But what I'm going to do is F11, which is step into, which means step through the program one line at a time. F11. So that saves, compiles, links, and runs the program. And here we see the yellow arrow indicating that's the next line to be executed, which in this case is the first line of code. And then we hit F11, which takes us to the initialization part of the loop, and then the test. And then we execute the loop having passed the test. And before continue, and then we check to see whether or not I mod 2 is equal to 1. And it isn't, so we write the output statement, bottom of the loop, then we do the increment, and then the test. We pass the test, we get back into the loop. So that gives you a little idea of how you can use the debugger to step through your code and how the continue statement works. So now I'll stop the program. And let's talk about one other possible flow of control statement that's similar and, in fact, much more popular than the continue statement, and that's the break statement. So let's say that as a result of running this code, you have something you'd like to test beyond just going through 10 times. So for example, I'll do some arbitrary calculation. It really doesn't matter what it is. Let me build that method. I'm going to right-click on it and select Quick Actions and Refactorings. And I'm going to generate a method stub for some calculation. And so here it is. And I will do something simple. And then the question is, if that sum calculation generates a value of 5, let's say arbitrarily, that I want to get out of this loop. I no longer want to execute the loop. So what I'm going to do is I'm going to say break. Okay, so break says leave So let's run this code and see what happens. So this time, our calculation never resulted in a 5, and we did the entire loop. But you'll notice that this time, our calculation resulted in a 5, and so we didn't execute the entire sequence of loop values, but only the first one. At that point, we hit the break statement, and that was the end of the loop. So that's the for statement, the continue statement, and the break statement.